Good morning, dear friends and students. In the morning session, again we are here discussing with the live discussion on lime soda process that we were discussing yesterday. Yesterday we have in detail discussion about hard water, hardness of water, and the various process which is used for softening of water. Now, when we consider the softening of water, then actually there were two different methods, that is the lime process and the soda process. Now, based on these lime and soda process, it was studied that a definite amount of lime and soda is added to water in order to remove the dissolved ions in the form of the precipitate from the solution. So certain chemical calculations has to be carried out, and when certain chemical calculations are being carried out, we will calculate what amount of lime or what amount of soda is actually to be added to the given hard water depending upon the hardness of the water, that is the composition of the water. For example, it may have different calcium and magnesium ion, etc. So today, as it is again a live discussion, I will be waiting for your queries. We will be discussing certain numericals and concept. I will just give a brief review of what we have discussed yesterday, and then we will start with the question answers that will be asked by you. Reverse.
ऑप्शन ही नहीं आ रहा
So, when we are considering hard water, then we have seen that the hard water, which imparts a type of property called as hardness of water, is of two types, that is temporary hardness and permanent hardness. Clear? So we have two types of hardness, that is actually the temporary hardness and the another one is permanent hardness. As we have discussed, the temporary hardness is also called as the carbonate or bicarbonate, and permanent hardness, it is actually the non-carbonate hardness. Then we have to determine these type of hardness that are present in water. Now, as we have discussed that these hardness basically bicarbonate ion, and they are removed by heating. Yesterday there was a query that why temporary hardness is removed by heating, whereas a permanent hardness cannot be removed by heating. The reason lies in the fact that bicarbonate ion, when heated, gets converted into carbonate ion, and for example, if we have this kind of ion, bicarbonate ion, and it is heated, then it gets converted into calcium carbonate, and therefore the precipitate of the calcium carbonate is produced. So it is actually removed. But if we have, for example, calcium sulfate, on heating, no effect is observed. So what happens is, you cannot remove this permanent hardness by heating, and the temporary hardness can be removed by heating. We also discussed various formulas for calculating the temporary and permanent hardness removal by addition of lime and soda. we can write it out as the total lime required is equal to 74 by 100. It is given as 74 by 100 multiplied by temporary calcium ion plus twice temporary magnesium ion plus permanent magnesium ion, aluminum ion, ferrous ion, etc. Remember, when you have a permanent calcium ion, it does not require lime. So what is temporary calcium ion? A temporary magnesium ion, and then permanent magnesium, aluminum and iron, etc. Then dissolved gases like carbon dioxide, mineral acids in the form of HCl, H2SO4, etc. And at the same time, if we consider two different ions which are used as an coagulant, that is bicarbonate ion minus equivalents of this. Now these all are to be represent, all are expressed as equivalents of calcium carbonate. This is the most important thing. That is, if you have water, if you have a sample of water and it has, say, calcium chloride 20 grams, then what you have to do is you have to convert this calcium chloride into equivalents of calcium carbonate. If suppose it also has calcium sulfate 10 grams, it is also converted into equivalents of calcium carbonate. Now how to convert it into equivalents of calcium carbonate? I'll give you a brief description of this also. See, the basic formula is substances react in the ratio of their equivalent weights. For example, if I am using calcium chloride and I want to find out what equivalent of calcium carbonate is to be used, then the basic formula that I have to use is weight of calcium chloride, weight of calcium carbonate is equivalent to equivalent weight of calcium carbonate or calcium chloride upon equivalent weight of calcium carbonate. Now here say 20 grams of calcium chloride is given. So what I want to find is, I want to find out what equivalent of calcium carbonate, represents 20 grams of is represented by 20 grams of calcium chloride. So what I want to find is this, the weight of calcium carbonate. So weight of calcium carbonate, which is equal to calcium chloride in terms of its equivalence, will be equal to the given weight of calcium chloride into equivalent weight of calcium carbonate divided by equivalent weight of calcium chloride. So what happens, say here it is given as 20 grams into equivalent weight of calcium carbonate. Equivalent weight here simply remember as equivalent weight is equal to molecular weight of the substance divided by total positive charge. There are different formulas which are used for calculating the equivalent weight. But simply here, since these kinds of substances are encountered in water, so you can simply calculate. For example, in case of calcium carbonate, the equivalent weight is, molecular weight is 100 and the total positive charge is equal to 50. So it will be 50 upon equivalent weight of calcium chloride, 40 plus 35.5 into 2. This is the molecular weight of calcium chloride divided by total positive charge. So it will be equal to 20 into 50 upon 20 plus 35.5, and on solving we will get 55.5 like this. So in this way, suppose the value comes out to be x. So what we have to do is, we have to convert each and every hardness causing substance into equivalents of calcium carbonate by using this using the simple formula that is, the weight of calcium carbonate equivalent will be given by the given weight of substance, or you can write weight of given substance that produces hardness into equivalent weight of calcium carbonate upon equivalent weight of the given substance. So by this you will calculate the calcium carbonate equivalent, and the total hardness will be obtained in terms of calcium carbonate, which will be expressed in ppm, that is milligrams per liter, that is 1 milligram raised in 10 raised to 6 parts of that water. So this was related to lime calculation. And similarly, if you have soda calculation, amount of soda, that is as soda required. If you are considering the amount of soda required, then see the molecular weight of sodium carbonate, 2 into 23 plus 12 plus 16 into 3, that is 106. So the amount of soda required will be equal to, that is, if you are considering this is in 100 grams, so in 1 gram of that particular thing, the equivalence will be calculated as 106 by 100 into the various substances which are producing hardness, and that to be converted in the calcium carbonate equivalent. So it will consider permanent calcium hardness, magnesium hardness, aluminum ion. We have discussed yesterday all these things, ferrous ions. Okay, then permanent these ions. Then we were discussing in case of lime, free acids were there, so they were producing the calcium sulfate and all. So again, the presence of mineral acids in the form of HCl or H2SO4. Then if it is bicarbonate, then we have actually the, since if bicarbonate ion is produced, so what happens is it reacts and results in the formation of the carbonate ion. So when bicarbonate ion is there, it actually reacts with lime, and carbonate ion in excess is produced, which itself is lime. So we have to subtract the value of this particular bicarbonate ion. And in case these are the requirement for soda, and again all are to be calculated as equivalents of calcium carbonate in equivalents of calcium carbonate. Then we can calculate the value of soda. So in this way, lime and soda requirement is carried out. Now, few things are to be noted down, and these are certain points that needs to be taken care when you are actually solving the numerical or when some query is given. The first thing is that if you have a temporary calcium hardness, then you have to use only lime and soda. If it is temporary magnesium hardness, then you have to use twice of lime. If it is permanent calcium hardness, see, if permanent calcium hardness is there, you don't try to do the question like this, that it will react with lime. No. In no way can calcium ion react with the calcium hydroxide. So the lime will not react with permanent calcium ion. So what happens is, it has to be reacted or removed with soda only. Calcium ion, whenever given, is treated as permanent hardness causing substance, and so what happens is soda. But if permanent magnesium ion is there, it does react with lime as well as soda both. Now the important thing is that if calcium ion is present, if in water the analysis part is given as the water contain calcium ion, then treat it as a permanent hardness. So when you are treating it as a permanent hardness, the calcium ion, since it is a permanent hardness, you can see that you have to consider it with soda only. And again, when it is magnesium ion, then again permanent hardness. If bicarbonate ion is given, if bicarbonate ion is present in the water, then you have to treat it as lime, and the requirement of soda is decreased by an equivalent amount of the bicarbonate ion that is produced, since it is actually resulting in the production of the soda itself. And if sodium aluminate, which is used as a coagulant, was added initially, then NaAlO2 is, if present, it actually produces on hydrolysis AlOH, and OH ion is produced. So what happens is, that is considered to be as equivalent, that is considered to be equivalent to lime. So what is to be done is, you have to subtract the given amount from lime, and then, as I have discussed earlier also, if you have raw water, which is actually nothing but a hard water, and you are treating it with lime and soda, what will happen? When you are treating it with lime and soda, you will get soft water. Now soft water will remove calcium, magnesium, etc. But what is happening is, you are adding lime in the form of calcium hydroxide and soda Na2CO3. These substances react with the hardness causing agent, but it may happen that excess of these substances are added. So when excess of these substances are added, the soft water may contain excess of OH ion and excess of carbonate ion. So these ions are present, they are not causing hardness, but they indicate that an excess of lime and soda is to be added. And according to the analysis of, so we do the analysis of raw water and the soft water. If the soft water analysis shows excess of OH ion, then in that particular case, what you have to do is, you have to consider it, that is, that excess equivalent is to be added in the lime requirement and soda requirement both. Now the question again is, why soda requirement? Because you are getting an excess of OH ion only, you are not getting an excess of calcium ion. And again, the calcium ion, as I have stated earlier also, is responsible for the permanent hardness, which will again react with an equivalent of the soda. So it will consume, and this ion was not present in the water. It is the ion that is added by us from the lime. So what is happening is that, so when you are using this excess OH ion, it indicates that lime and soda addition both should take place. And similarly, if you have excess of carbonate ion, it shows that you have to add an equivalent amount in only soda. So again we can see that these things and these tips are actually used for calculating various kinds of things. And I am interested to know if any query now, as I have discussed here, so I am interested to discuss any kind of query till if you have any. Change reverse. So friends, if you have any query regarding this process, the formula, etc., you can actually send your message, and you can even WhatsApp to me so that I can give the reply later on also. So the main thing is that it's an effort to discuss as a teaching, and I'm not physically present near you, but digitally we are connected. So it's an effort so as to explain this kind of thing. If I don't receive a query, then I'll take two numericals and try to solve so that you can be familiar with how these questions are actually solved. So again, I think we can summarize what we have discussed. We have discussed how to calculate the equivalence of lime and equivalence of soda, and at the same time we have discussed the formula for calculating the lime that is to be added to the water, and then actually the formula for calculating the amount of soda that is to be added in the water, and the various tips. For example, if you have an excess of bicarbonate ion, the sodium aluminate, the excess OH ion, etc. Now we will discuss this with taking few examples. Now, it is given that a sample of water on analysis has been found to contain the following impurities. Shows following impurities: magnesium bicarbonate 14.6 milligrams per liter, magnesium chloride 19 milligrams per liter, then magnesium nitrate that is 29.6 milligrams per liter, calcium carbonate that is calcium carbonate 10 milligrams per liter, then magnesium sulfate, it is 36 milligrams per liter, then sodium chloride equal to 29 magnesium milligram per liter. Calculate the temporary, permanent and total hardness. Calculate the temporary, permanent and total hardness of water sample in ppm, of water sample in ppm. See, when we are using this thing, a sample of water or analysis shows 1, 2, 3, 4, 5 and 6 impurities. Yes, definitely they are producing the hardness. That is, they make water less. They make water convert into a type where it produces less leather with this soap. One more thing that is to be taken care of: sodium chloride, potassium chloride, SiO2, etc. They do not cause hardness. They do not cause hardness. It means why? Because sodium chloride, potassium chloride, and SiO2 do not react with the molecule of soap. They are not reacting with the molecule of the soap, and therefore they are not interfering in the process of leather formation. Since they are not interfering in the process of the leather formation, so even if the amount of sodium chloride is given, it is not considered for calculating the lime and soda requirement. Now the first thing here is that, as I have discussed earlier also, the first step that we have to perform is to calculate the equivalence of calcium carbonate in these substances. That is, we will calculate calcium carbonate equivalent. And I have discussed the formula of calculating the calcium carbonate equivalent also, like weight of calcium carbonate upon weight of substance given is equal to equivalent weight of calcium carbonate upon equivalent weight of the given substance producing the hardness. So weight of calcium carbonate, which is equivalent to the weight of the substance given, magnesium bicarbonate, it is equal to 14.6 into equivalent weight of calcium carbonate upon equivalent weight of magnesium bicarbonate. Again, we'll discuss this one point and simply write so as to avoid the time. See how to calculate the equivalent weight of calcium carbonate. Calcium carbonate molecular weight divided by total charge present. So molecular weight is 100 by 2. In case of magnesium bicarbonate, molecular weight can be calculated as atomic weight plus 1 plus 12 plus 16 into 3 multiplied by 2, and upon this is the molecular weight, so it comes out to be 24 plus 48 and 13, that is 146. So equivalent weight will be 146 by 2. So how to calculate? It is 14.6 into 100 by 2 divided by 146 by 2. So in this way we will get an amount. In this way we will get an amount so that it will represent equivalent of calcium carbonate. In the same manner we will calculate the equivalence of magnesium chloride, magnesium nitrate, etc. I will just write out, just sum it out so that you can have an idea about how to write or how to observe, solve this kind of question. So first thing is we will write the equivalent. This is the amount of substance given, and then the multiplication factor, which is nothing but equivalent weight of calcium carbonate upon equivalent weight of the substance. So it is 100 by, for magnesium bicarbonate it is 100 upon 146. We have calculated this value. Then it is 100 upon 96, 100 upon 148, 100 upon 100 for calcium carbonate, and 100 upon 120. So when you multiply these two factors, then you have, that is, you will be having 14.6 into 100 upon 146, then 19 into 100 upon 96, 29.6 into 100 upon 148, then 10 into 100 upon 100, and 36 into 100 upon 120. So on solving this, we will get as 10 20, 20, 10 and 30. Now the important thing here is that this is the manner. So first thing done was to calculate the multiplication factor, that is E1 by E2 multiplied by the weight of the substance using this simple formula, and you are getting these substances as equivalents of calcium carbonate. Now you have to use the particular formula. When you are using the particular formula, see, first of all, we will try to calculate temporary hardness. If I say you just simply have to calculate temporary hardness, then what you will do is you will calculate the total amount of the substances which produces temporary hardness, and that is basically the bicarbonate ion, and the calcium carbonate is also considered for the same purpose. So simply add them, and 10 and 30 that comes out to be, so that will be actually the temporary hardness, and then actually consider the permanent hardness. So when you are calculating the permanent hardness, what you have to do is for calculating this permanent hardness, you have to consider the substances like magnesium chloride, then you have magnesium nitrate, magnesium sulfate, and you simply add. I'll just sum up what answer is there. So temporary hardness is, so it is given as the temporary hardness is due to magnesium bicarbonate and calcium carbonate. That is, magnesium bicarbonate, it produces temporary hardness, and then this is again also the temporary hardness. So you just simply add these two values, and this will give you the value of total temporary hardness, and remaining 1, 2 and 3, then actually the permanent hardness. Now if the same question is modified in a manner to calculate the lime and soda requirement, so temporary hardness is to be calculated as total hardness minus temporary, total hardness minus this permanent hardness. Or you can simply say that if you want to calculate the total hardness, then simply add them. So the total hardness is the sum total of temporary hardness and the permanent hardness. So add the values again. Now the important thing here is that if you want to calculate the value of lime and soda using this factor only or this numerical, then we can use the formula as lime required is equal to 74 by 100 upon. Now you have to see what substance is given. Lime, as you can see, you can have different types of formula. So based on that formula, you can again correlate this kind of thing. That is, if you have so as to correlate. See, lime required is given as 74 by 100 into temporary calcium ion. So where is temporary calcium ion? There is no temporary calcium ion. You don't have to consider this. Then temporary magnesium ion. Here you have, so you will write as 2 into magnesium bicarbonate. See, here it was price of lime. Magnesium chloride, it is permanent. So permanent means lime as well as magnesium chloride means lime and soda. Magnesium nitrate, again it is lime plus soda, both will be required. Calcium carbonate, only in this particular case it is treated as a calcium carbonate, bicarbonate, and in the same manner. So what you have to do is you have to consider it only as, and then again magnesium sulfate, so lime plus soda. So using this formula, see, temporary twice of temporary magnesium carbonate, then permanent magnesium hardness. So you can see that these three were the permanent magnesium hardness, and they are using the lime also. So you have equivalents: magnesium chloride, then magnesium nitrate, and then magnesium sulfate, and then no carbon dioxide, acid, bicarbonate or sodium aluminate is given. So simply, as they are converted into calcium carbonate equivalent, you just substitute the value and multiply it by 74 by 100. So you will obtain, now depending on whether you have calculated it in gram or kg, you will get the amount of lime. Similarly, if you want to calculate soda, it will be 106 by 100. You can use the formula. 106 by 100. Permanent calcium, magnesium, aluminum, iron or acid, and this is actually the bicarbonate ion. So it is bicarbonate, that is the free bicarbonate ion that is actually present, not in the combined form as you are considering here. So what is obtained is 106 by 100. Now you can see that soda required, permanent magnesium ion. So what will happen is you will consider it as magnesium chloride, then again magnesium nitrate, then magnesium sulfate. So in this way you can see that only these three terms are used for calculating the requirement of soda. Now this is say for 1 ml of water. Now suppose for 1000 ml into 1000. If you want to calculate it for V ml of water, V liters of water, then you have to multiply it by V. For number of days or number of operation, depending on the question, that is actually given. So in this manner, by using these formula, you can easily calculate the various lime and soda required. So change them. This was the manner how we have. This was actually the manner or the method by which we have actually calculated the various requirement of lime and soda, and these two method or these two formulas are actually basically used for calculating the lime soda requirement. And since we have discussed that there was another method called as the zeolite method, and the same method was also utilized, and the regeneration of the zeolite is also done, that is again a numerical formula. So with this I will now end the session, and again I suggest all of you to kindly send your queries so that this kind of interaction session can be made fruitful for you. Thank you.